So I'm a senior software engineer at Devetry. I really like SQL, TypeScript, Python. We're talking about two of those today, so I'm happy. And I love teaching and learning from others, so I'm excited to see some of the use cases presented today. As far as SQL, just a quick overview, and then we'll get to the use cases. What is SQL? SQL is a rough name, and if you say SQL or if you say SQL, both are totally valid. Both are accepted. You'll hear people argue for one over the other, but I think they're both fine. But it's a family of programming languages for communicating with a database. There is a standard, but particular database vendors like Oracle or Postgres or Microsoft will go in different directions a little bit. And so the languages aren't all identical. That's why I say they're a family of programming languages. What does it look like? I feel like this is a good place to start. So there's a handful of examples I put together. The first one is a fairly simple select. So select first name, family name, join date from mailing list, where join date is before 2020-03-01, so March 1st. This is a fairly simple query as they go. From this, we can assume that there's some table in the database called mailing list, and these are columns that we're selecting out of it. Maybe there's more columns than we see here. These are the only ones we're asking for in the result. You can query SQL, and from talking with product managers, that's mostly what people use it for. As a developer, I use it also for inserting and updating existing records in the database. So this is an example of what a insert might look like. You can see there's a little bit of funniness with the apostrophe here, because the apostrophe is like, how does it know that that's not the end of my book title? And with Postgres, the style is to use a double quote to say, I wasn't finished yet, just put one here. A little bit funky. You can do an update. So update users, U, and in this, I'm getting an alias. U is going to be an alias for a particular user. And we're going to change it so that the last active date is the current timestamp and accepted terms of service is true. But we only want to change that if the user ID it matches some made up number. And then finally, just for a little bit of variety, I threw a somewhat more complex query in. This uses a feature called common table expressions, where you can build up like intermediate tables. So borrows by person is a table that I'm going to go on to use later on, but it only exists for the life of this query. So SQL, even though the first couple of examples are fairly simple, it gets pretty crazy, and it gets yet crazier still. The other feature I want to point out here, if the text isn't too small, is this idea of a join. Database tables tend to be like as small as they can be without losing information. So rather than duplicate information, so this looks like it's a library database perhaps. So we have tables called book and book copy. So if you're experienced at looking at databases, you would understand that the book table has details about a book. The title, the year it was published, maybe a price if it's like a retail store. It probably has the ISBN. But what it wouldn't have is like the date it was purchased, or any notes about this book is in poor condition at this point, or things that pertain just to a particular copy. Instead, what we're going to do is have a foreign key relationship. So a book copy will say, here are the details about specifically just this physical copy of the book. And if you want to learn which book I'm even talking about, you'll have to use my book ID to look that book up. And that's really a powerful thing about SQL databases. It allows us to avoid, whenever we duplicate information, right, there's the potential for that information to get out of sync. You can imagine if we stored the title on every book copy, that maybe there was a typo and we want to change all of them. It would be easy to accidentally miss a couple or something like that. And so this structure where we store as little data as we can get away with and still have the whole system make sense is called denormalization. And it's one of the principles of good SQL database design. Let me pause here. Allegra, you're handling questions, right? How are we doing with questions?
We don't have any so far.
Okay. And I guess no one can unmute themselves. So I'm really happy to take questions. I'll pause a couple more times, but there's no way for you to like talk out loud to me. So you'll have to type through the box. If you are curious about something, I'm planning on leaving plenty of room for questions. Feel free to ask them in the box. Okay. Have I lost control of the screen? There it goes. Okay, so SQL, what's so great about it? It has a huge community because it's been around so long, and also just because it is the most common and popular way to put together almost any web app, and almost every web app is going to need a database. There is a really big community. Lots of people who can help you with it, lots of people who understand how to use it and can give you pointers. Also, because of that huge community, there are excellent tools for every operating system, for every database, for interacting with a database. My personal favorite is one called Postico, but it's macOS only. There's also one called Table Plus. I'll drop links later. The other thing that's really nice about it is that it has well understood operational needs. So there are newer technologies that exist. There was a whole explosion of them over the last 15 years or so, but none of them are quite as well tuned or well understood as plain old relational databases, SQL databases. One point that's really important to me, and especially in it has been incredibly useful when a product is sort of evolving and it's not in its final stage yet, which is maybe true of every product, is if you can ask a question about your data, you can ask it in SQL. So that doesn't mean you had the foresight to, that doesn't mean you necessarily had the foresight to include all of the information or hold on to all of the information you would need in order to ask that question. But let's go back to that library example. Let's say you wanted to find all the books where one person made up at least 20% of the checkouts of that particular book title. Like not a physical copy, but one person just absolutely loves Harry Potter and the Sorcerer's Stone. That's sort of a convoluted question. There's no one who would have thought to be like, oh, we're gonna need to be able to tell when someone has such a favorite book that they make up more than 10% of the checkouts of that book. Let's make it a little more complicated. And there's at least 100 checkouts of the book, or, you know, something like that. Any question like that that you can phrase, you can ask it in SQL. And that's really powerful. SQL also gives you guidance on how to lay out your data. That's that normalization thing that we've touched on before. Those normalization patterns they were kind of developed at the same time that the idea of databases were developed. And they turn out to be really useful and powerful in making sure that you can ask all those increasingly complex questions about your data. And in making sure that your, like when someone changes their address, it doesn't cascade to 100 different records you have to track down and update. So I've been dancing around this, but the point that makes me most excited about SQL databases is that if you do the work of setting up a good structure at the beginning, then you can figure out query patterns later. And what, as it turns out, structure is the structure of your data, like who owns which pieces. Like often if in a regular web app, someone will like own a document or own a team or something like that. If you tend to need to make those decisions in order to set up your SQL schema, that's what your structure is often called. But once you make all those decisions, it gives you lots of freedom to figure out query patterns later. That is in contrast to some other database technologies where you need to know at the very beginning what are all of the queries, what are all the questions we're going to ask of our data, and you need that information before you can decide how your database is going to be organized. I think that is antithetical to a lot of the modern ways that we like to develop products. We want to be able to change our minds about what's important, to like what questions are important, and to have to throw away a whole bunch of data that we've already collected because we didn't foresee the need to ask a particular question is distasteful. So what's not so great about it? Every technology has trade-offs. Several dialects. This SQL is a family of languages again. So that means that Microsoft SQL Server isn't going to work quite the same as MySQL, which isn't going to work quite the same as PostgreSQL. It's not awesome at handling heterogeneous data. An example of heterogeneous data would be like a list of events, and each event might need different attributes. So an event might be like document created, and it might include the title, and then like collaborators invited, and it might include, or collaborator invited, and it might include a user ID. It's not going to be excellent at handling that kind of data if you were trying to store it all in the same table. But some databases, particularly PostgreSQL, which is my favorite, is going to do a reasonably good job. And then finally, there's a class of queries that are a little bit awkward to phrase. They're called friend of a friend queries, but they come up in other avenues than just social networks. One example would be if you were trying to find, say you have like a hierarchical org chart, and you're trying to find all of the people under this person's subtree of an organization. Like, I'm the manager, I want to find all of my direct reports and all of their direct reports and all of their direct reports and so on. That question can be asked, but it's a little bit awkward, and the query ends up looking a little ugly. Let me pause here and ask for questions again.
Sure. So when we were talking a little bit about the layout of the data, some of the distribution work that you talked about, can we pull back a little bit and kind of understand how a PM would even go about learning what fields exist so that they know what to look for in a query? That'd be helpful.
Yeah, definitely. Unfortunately, this is Brennan's screen. I'd love to be able to pull something up from my computer, but I'll just have to describe it. There is a query that you can write to, oh, will this work? Awesome. I'll just go ahead and share my screen. Okay, so what other databases do I have here? We're going to connect to Develop Denver. So Denver is a conference I'm involved with, and I helped make the website last year, so I still have access to the database. So right away when I've connected to the database, this is that Postico client I was talking about. It gives me a list of all the tables. And so let's say I'm interested in talks. What are the types of talks? I can click into it and just see a big list of every talk that was submitted, but I can also go and look at the structure and see that the columns are ID, title, type. I'm like, type, what does type represent? Maybe I want to get a full, like, what are some examples of type? So SQL queries can often be kind of a conversation. So I'm like, most of these are talk. What are all the unique ones? So I can ask for select distinct type from talk. And it will tell me these are all of the possible types of talks in our database. You've got events, performances, talks. The other thing that I find useful is, especially in clients, a client is a word for like an interface to a database, like a user interface. So in user interfaces that don't give you this nice structure view, you can also say, give me all the columns. I want every single column. And so it's going to give me all the rows, but it also, you can see it gave me every column back. And then if you don't even know which tables to ask for, most databases have a way to say what tables exist. In Postgres, this happens to be the way it works. And so you can see table shows up. We've got talk, vote, venue. There's a handful of system tables. So it's pretty interactive, and it tends to be happy to show you what data it contains.
Thanks very much for that, Brian. We'll be able to come back to questions in just a little bit to take on some more.
Great. Okay. Do you want to share your screen again, or should I take over the presentation? You've got it. Great. Okay. What's not so great about it continued. There are more things. When your data gets really big, and I'm not talking about that, I'm talking about bigger than that. And even bigger than that, you can run into scaling problems. Databases are notoriously, in any like really big web app, they are the hardest piece to scale. But by the time you've reached this point, you understand the problem much better than you did at the beginning. And if you need to, you're ready to move to a column-oriented or distributed NoSQL DB, like Cassandra or DynamoDB, that those databases are more restricting in the types of questions you can ask of the data efficiently, which questions you can ask efficiently. But by the time you've reached this scale, hopefully you understand the problem well enough that you know which types of questions you're going to ask of each table. You also have the money to hire people who can set up Cassandra or whatever you choose. SQL databases are cheap. They're easily understood. Every bootcamp grad knows how to set up a SQL database, whereas NoSQL and Cassandra tend to be more niche skills. And then finally, I just want to say, your data isn't that big. There are only a handful of people who ever run into this problem. I think NoSQL got really popular because the Facebooks and Twitters and Googles started running into this problem, and everybody wanted to be like them. But we just don't have the same problems. We have an entirely different set of problems, and we need to optimize for a different set of goals. So we've kind of addressed this already. I've heard about this NoSQL thing. Isn't SQL outdated? I would say that it's well understood. It is an old technology, but it's really still the most popular database technology used today. And we've gone over this, I maybe got ahead of myself, but I think SQL rocks because it forces you to come up with this schema, this organization ahead of time. You have to think about how your domain entities relate to one another. And you can make changes later, but you're never going to end up in a situation where your data is structured in two different ways. And the new data has one format and the old data has another, and your code has to compensate for it. Instead, the constraint of having a SQL database with a single schema is going to force you to migrate all of your old stuff to the new structure if you decide to make a structure change, or to think about the structure much more carefully at the beginning. Brennan, how am I doing on time?
Running a bit long.
Okay.
But that's okay.
Let me just skip the, there's an example here. I think there's some lag with me controlling your scheme or your screen, but let's see.
And I think the problem is I accidentally keep taking control away from you, and I apologize.
Oh, okay. Sorry about that.
If you use the arrow keys on your computer, it should work.
Great. Okay. So this Sarah May blog post has a good example of when this product thought, oh, we don't need relational data. We have a perfect use case for a NoSQL database. And it turned out, no, some of the questions we wanted to ask of that data were very difficult to phrase in MongoDB, and they ended up doing a very painful migration. But I'm not going to talk about that for want of time. And we've kind of covered all of these things. Postgres can be as faster than MongoDB. It just doesn't have a commercial marketing team behind it. And if you're interested in learning SQL, there are some excellent resources online. Select Star is really good in particular. The SQL Police Department I just found out about a couple days ago. And then these last two I've used in classes before. The final one I actually wrote. So those links, we'll make sure those are available and sent out to the group. And sorry about running a little long.